Welcome Algebra 1. This video is on multiplying binomials. The essential question is, how are you going to multiply binomials? Let's begin. So this is what I mean by multiplying binomials. You're taking two binomials, like x plus 5 times x plus 2, and multiplying them, and you get some answer like x squared plus 7x plus 10. And here's a bunch of different examples of that. So how do I do this? Well, that's the big question. How do you multiply that? And there's a few different ways, and if you ask different teachers, they'd show you different ways. But I'm going to teach you two different ways, and you can choose to do it any way you want. I don't care if you choose one of these or you choose a different one. The first method is to use a box. If you like drawing pictures, use the box method. The second one is using FOIL. If you just like to multiply numbers and think about this algebraically, you don't need drawings, then FOIL might be good for you. So anyways, let's start with the box. So let's take that first example of x plus 5 plus x plus 2. How did I get this answer? First way you can do this is you can create a 4-square box. So 2 by 2, so 4 squares, 1, 2, 3, 4. Now, you put the binomial terms on the left and the top. So for example, the way this looks is I put the x and then the positive 5 up here. Let's call this a plus 5. And we put on the left side, I can put the x and the positive 2 over here. All right? So on the top and the left, the binomials. The second step, and it's not part of here, we want to multiply, and 2.5 steps, multiply rows and columns. So rows and columns. What do I mean by this? You're multiplying the row times the column and putting it in the box. So x times x is going to be x squared. X times 5 is going to be 5x. 2 times x is going to be 2x. And 2 times 5 is going to be 10, just 10. Now what I want you to do is add all these squares up. And while you're adding, you're going to also combine like terms. So these two steps should actually be together. So you add the squares and combine like terms. The neat thing is that usually this diagonal is going to be like terms. So if I'm adding these up, I'm going to get an x squared from this top one. 2x plus 5x is going to be 7x, and then a 10. So x squared plus 7x plus 10, which is what I got. All right? Let's look at another example. So I'm multiplying a binomial times a trinomial in this case. So that doesn't exactly work with that box method. We don't have enough boxes. What you have to do, since that one was 2 by 2, we need to make this a 2 by 3 because there's 3 terms here. So I'll do the same steps, except make a 2 by 3 box. And I'm going to put the binomial, the k, and the negative 1 on the left. And for the 3 terms in the trinomial, I'm going to do 6k squared, and then positive k, and then positive 3 on the top. Now you multiply the columns and rows again. So k times 6k squared is 6k cubed. K times k is positive k squared. K times 3 is 3k. 6k squared minus times negative 1 is negative 6k squared. Negative 1 times k is negative k. Negative 1 times 3 is negative 3. So adding these up, a neat thing is here, these are both k squared, so those are like terms. And these are also like terms as just k. So I have a 6k cubed by itself, so 6k cubed. Negative 6k plus a k squared, that's like a 1k squared. So negative 6 plus 1 is going to be negative 5k squared. Negative 1k plus 3 is going to be positive 2k, and then a negative 3 at the end, which matches what the answer is supposed to be. Let's do another one. All right, n minus 7 times n plus 7, n squared minus 49. Wait, where did that middle term go? Usually there's like an n term. I don't know where this n term went. Let's find out. So I'm going to set up my box, n minus 7 on top and n plus 7 on the side. N times n is n squared. N times negative 7, negative 7n. 7 times n is 7n. And 7 times negative 7 is negative 49. Now if you're adding up these like terms, the 7 and negative 7, well, let's work this out. N squared is going to be n squared. 7 minus 7 is 0n. So when you have 0n, you just don't need to write it. So that's what happened. It was 0n. And go minus 49. And that's what my answer is. Let's try another one. Pn minus 5 squared equals p squared minus 10p plus 25. Wait, what are the two binomials? Well, since you have p minus 5 squared, that's like having two of those. So another p minus 5 here. So squared just means you have two of them. So I'll do a p minus 5 here and a p minus 5 here. P times p is p squared. P times negative 5 is negative 5p. This will be negative 5p. And this will be positive 25. So adding up like terms, these two are like terms. So I'm going to get a p squared. Negative 5 is negative 10p. And plus 25. And that matches up. Now let's try it with the FOIL method. So FOIL method, we don't draw boxes. We have to multiply it out. It's kind of like it's a distributive method. It's like using distributive property, but just using it a bunch. So the FOIL stands for first, outer, inner, last. That's what FOIL. So first means, and I did this binomial over here, you're multiplying the first two of each binomial. So x times x, and that gets you x squared. Outers mean just the outer ones, so the left side of this and the right side of that. So x times 2 is 2x. Inners mean the two inside ones, 5 times x or 5x, and the last means the last number on each one. So 5 times 2 is 10. So what does that look like on an actual problem? The way I do this is I draw an arc, so go those are the first. So x times x is going to be x squared. And actually, let's not write that right there. So that's going to equal x squared. And then the outers, x times 2 is going to be positive 2x. Then the inners, 5 times x is going to be plus 5x. And then last, 5 times 2 is 10. So now that I got x squared plus 2x plus 5x plus 10, what's a like term? 2x and 5x combine to 7x. So I'm left with x squared plus 7x plus 10, and that matches up. Try a different one. Okay, so if you have the binomial times the trinomial, FOIL doesn't exactly work. It's kind of treat it like a super FOIL. So the way that works is k times 6k squared is going to be, well, 6k cubed. And then you go k times k is going to be plus k squared. K times 3 is going to be plus 3k. All right? And then you go negative 1 times 6k is minus 6k squared. And negative 1 times k is negative k. And negative 1 times 3 is negative 3. So it's not just first, outer, inner, last. There's a bunch of middle ones too. But as long as you're kind of distributing to all three and then distributing to all three with each of the terms in the binomial. So let's combine like terms. 6k to the third is by itself, so just 6k to the third. K squared and negative 6k squared, so that's 1 minus 6 is negative 5k squared. 3k and negative 1k are going to combine to plus 2k, and then you have a minus 3, so minus 3, which matches what I got above. The next one, this is where it disappeared, so what happens here? Well, n times n is going to be n squared. N times 7 is plus 7n. Negative 7 times n is minus 7n. And negative 7 times negative 7 is negative 49. So combining like terms, the 7n and minus 7n combine to 0n, which just goes away. So all I'm left with is n squared minus 49, because this just went away. And the last one. All right, you got p minus 5 squared. When you have two of these, when you have that squared, that means we have two of these going on. So I just cross off the 2 and write another p minus 5. So let's FOIL that. P times p is going to be p squared. P times negative 5 is negative 5p. Negative 5 times p is negative 5p. Negative 5 times negative 5 is positive 25. Now, combining like terms again, negative 5p is negative 10p. So dropping down the 25 and drop down the p squared, there you go. Same as the answer above. Let's do some examples. Pause the video. All right, there's coefficients to these variables, but that's okay. I'm going to do the FOIL method for this one. 2n times 3n is going to be 6n squared. 2n times 8 is plus 16n. 11 times 3n is plus 33n. And 11 times 8 is plus 88. Combine like terms right here and here. You're going to get 6n squared. And then 16 plus 33 is going to be 49n plus 88. That's your answer. And if you wanted to do a box, the box would look like this. And 2n plus 11 and 3n, I put xn plus 8. It doesn't matter if you put it on the top or bottom. You can change the order of that. So I get 6n squared, 33n, 16n, and 88. Combining those, you know that diagonal is actually going to be like terms. So I'm going to get 6n squared plus 49n plus 88, and that matches up. All right, next one. Okay, so I'm going to do the FOIL method first. 6p times 4p squared is 24p squared cubed. 6p times negative 6p is negative 36p squared. 6p times 5 is plus 30p. 7 times 4p squared is plus 28p squared. 7 times negative 6 is going to be negative 42p. And 7 times 5 is going to be plus 35. Combining like terms here, well, the cubed is just going to be the only one, so 24p cubed. Negative 36p squared and 28p squared are going to combine to negative 8p squared. 30p and negative 42p is going to be negative 12p. And then a plus 35 at the end. All right. If we did the box, I'm going to just do the box in the next problem. Pause the video. All right. So, I got cubes in here and I'm missing the squareds, but don't worry, still follow the same way. I'm going to do the box for this one though. Save me some time. So, x cubed and then minus 5 and x cubed minus 5. All right, so what does that multiply to? X cubed times x cubed, that's going to be x to the 6th. X cubed times negative 5 is negative 5x cubed. Negative 5, this will also be negative 5x cubed, and this will be positive 25. Adding those up, and this diagonal is like terms, so it'll be x to the 6 minus 10x cubed plus 25. Next one. Pause the video. I'm going to use FOIL. I got a squared here. I'm just going to erase that squared and write 3m plus 8. M, not n. And now I'm going to FOIL that. So 3 times 3m is going to be 9m squared. 3m times 8 is plus 24m. 8 times 3m is plus 24m. And 8 times 8 is 64. So adding those up, I got like terms on 24, so it's 9m squared plus 48m plus 64. That's it.